In this video, we dive into the gear tooth force analysis. The video is made of 3 chapters. First, we will discuss the assumptions for gear tooth analysis. Next, we will move on to the derivation. Finally, we will explore the directions of tangential and radial components of force. The analysis of gear tooth force hinges on a few key assumptions that shape our understanding. First, as the contact point shifts, the magnitude of the resultant force, Pn, changes, but we often overlook this dynamic aspect. Then consider that typically we assume only one pair of teeth bears the entire load. In reality, there can be 2 pairs in contact, sharing the load, yet this complexity is ignored in our analysis. Lastly, we base our findings on static conditions, which means we're looking at gears operating at very low velocities. However, in practice, dynamic forces come into play alongside the power transmission forces, but we set those aside for simplicity. These assumptions are crucial for simplifying our calculations, even if they don't capture the full picture of gear interactions. In gears, power transmission hinges on the interaction between the driving and driven gears. Picture this. The tooth of the driving pinion exerts a force, known as Pn, on the meshing tooth of the driven gear. This force follows the pressure line, a fundamental principle in gearing. Now let's break down Pn into 2 components. First, we have the tangential component Pt. This is where the magic happens. It's the useful load that drives torque and power transmission. Then, there's the radial component Pr, which acts as a separating force, always pulling towards the gear's center. The torque transmitted by the gears is given by this formula. Mt is equal to 60 into 10 to the power 6 times kW upon 2 pi n, where Mt equals torque transmitted by gears in Nmm, kW equals power transmitted by gears in kW, and N equals speed of rotation in RPM. The tangential component Pt acts at the pitch circle radius. Therefore, Pt times d dash by 2 is equals to Mt, or Pt is equal to 2 times Mt upon d dash. From the figure shown, Pr is equals to Pt times tan alpha. The resultant force Pn is given by Pn is equals to Pt upon cos alpha. The directions of 2 components Pt and Pr are decided by constructing the free body diagram. It is assumed that the pinion is the driving element while the gear is the driven element. It is assumed that the pinion rotates in anti-clockwise direction. Therefore, the gear will rotate in clockwise direction. In running condition, the point 2 on the pinion and the point 1 on the gear are in contact with each other. The gear G is the driven element. It is made to rotate in clockwise direction. Therefore, at point 1 on the gear G, the tangential component point will act towards the left. There will be equal and opposite reaction at point 2 on the pinion P. It is observed that the direction of tangential component point on the driving element, that is, pinion, is opposite to the direction of rotation. The radial component acts towards the center of the respective gear. For pinion P, the radial component PR acts at point 2 towards the center O2. For the gear G, the radial component PR acts at point 1 towards the center O1. We hope you find the video useful. Do share your thoughts in the comment section and don't forget to subscribe.